I'm going to start the lesson recording. At this point, you have finished your first inquiry question on Module 6, acid-base reactions. You know how to name and write the formula of your acids and bases. These are ones you have to have memorized. So either go back to your list, make a sticky note, put it on your wall so that you see it often, or just go back to the lesson recording. You know what indicators are, you know how they move back and forth to get a particular color in an acid or a base. You know how to write equations for acids and bases. This is revision from year 11. You know your Q is equal to MCAT calculations for enthalpy of neutralization. And from last lesson, you know the definitions of an acid and a base, and you know how to do your short answer questions about, is the Arrhenius theory any good? Is the Bronsted-Lowry theory any good? That was your quiz that you just did. The Bronsted-Lowry theory is the one that we use moving forward. I told you guys last lesson, if it's a long response question, you can mention the Lewis theory, which is the best definition of an acid and a base, but Bronsted-Lowry is what we use. Yeah. So today marks the never-ending start of your calculation questions in Module 6. Okay, I promise there's an end, but it'll be a little bit far away. Yes, I'll let you know when the end comes, but for now, prepare yourselves. We're going to start doing your calculation questions today. Just like how in Module 5, the main thing that you guys calculated was your equilibrium constant K. The main thing we calculate in Module 6 for acids and bases is something called pH. Okay, now before you even do the calculation for pH, just know pH is something you use to measure an acid or a base. And guys, generally speaking, at 25 degrees Celsius, we have to relate it to temperature. You'll see why in a second. But for now, at 25 degrees Celsius, if you have a pH less than 7, when we do the calculations or when you use a machine, that means it's going to be an acid. And if it's a pH greater than 7, that means it's going to be a base. Okay, or it's an acidic solution or it's a basic solution. You can write it down that way. pH is less than 7 is acidic, pH greater than 7 is basic. Now, guys, pH is equal to 7 means that it's not swaying too close to the acid side, it's not swaying too close to the base side. So what do you call that starting with an N? When you have a person that's like not biased towards one thing, not biased towards another, starting with an N. It's neutral. Good. If you have a pH equal to 7, that means it's not too acidic. That means it's not too basic. If you have a pH is equal to 7, it's a neutral solution, water, for example. The first syllabus dot point in this inquiry question is just how are you going to measure acids and bases? You're just going to take a pH probe, you're going to pluck it into whatever solution, you're just going to wait for it to read a number, yeah? So really straightforward. The only thing I want to mention to you here is anytime you're using machines in chemistry or in science in general, you want to make sure that you calibrate it, okay? Calibrating it means making sure basically making sure it reads the correct number, making sure it reads the true value. Basically, it's like just imagine like you're teaching someone to read. You know that it's the number 3. You want to make sure they also read the number 3 and don't blurt out number 2. Yeah. So when you're calibrating a machine, if you want to make sure it reads the true value, you need to know what the true value is. Okay, I can't teach you chemistry if I don't know chemistry myself. Yeah. So when you're calibrating a machine, before you start putting your pH probe into things that you don't know, you need to take a solution that you definitely know has a pH of, I don't know, let's say 7. Calibrating it means you put it into that solution and make sure it reads number 7. Yeah. Um, the solution that you use to calibrate normally comes with the machine. So like when your teacher gives it to you, they should have it in a box and then it'll have some solutions in there. So you're not making up your own solutions. It's just a really quick pop in, make sure it reads the correct number, and then just clean it, pop it into something else. So this is for any time you're using machines, in particular for this, when you're using a pH probe or a pH meter, pretty much the same thing. You want to rinse it in between every one, because if you dip it into an acid and then you dip it into a base after, you've now mixed the acid and the base together and it might not read the correct value. Yeah. So first thing you want to make calibrate it. And then number two, when you're switching between solutions to figure out the pH, just rinse it a bit with distilled water or with some deionized water is the other word. Yeah, distilled water or deionized water, just so that you don't have any traces of acid when you're trying to figure out if it's a base, or you don't have any traces of base when you're trying to figure out it's an acid. Yeah? Okay, that's pretty much it. That's the machine. Okay, your equations for pH. Grab this down, grab this down. pH is negative log base 10 of the concentration of hydrogen ions. And pOH, you just put the different formula in. pH is negative log base 10H. So guys, pOH is negative log base 10, the concentration of OH minus. Okay. Now, guys, you know when you were writing your equations last week, did you have your cameras on so I can see you? Because these questions are a little bit short. When you had H plus last lesson, when you were writing your equations, if it was an acid, what did you give away the H plus to? When you were writing your equations last week, remember what we said? It was always acid or base plus this other thing that was also on the left-hand side of your arrow. Water, yeah, it's always with water. So whenever you're writing your equations last week, it was, I don't know, HCl plus H2O, or it was NH3 plus H2O. So I know the acid pops off the H plus, but the H plus doesn't really float around. The H plus gets given to the water, and then what does water turn into on the right-hand side? Hydronium, yeah, it always turned into H3O plus. So as I know H plus is the thing that the acid gives away, but whenever you wrote your equations, it was never floating on its own. You always gave it to the water and it always turned into H3O plus. So the equation is negative log base 10H, but it's pretty much this as well. Pretty much the same thing. Because every one of your H plus adds on to the water and it turns into H3O plus on the right-hand side. Yeah. So these two, pretty much the same thing. The reason I want to give you this is because when we do the calculations and when you write your equations, you won't see H plus, you'll see H3O plus because that's what we do. So you might be like, okay, then where's H plus? It's the same thing. Okay. If you rearrange this, it's just algebra, or not even algebra, it's just rearranging the equation from maths. So if pH is negative log base 10 H plus, then H plus is 10 to the power of minus pH. Okay? If you are curious, go ask your maths teacher. Okay? You're going to bring the base to the other side, and then the thing on the left goes up to the power. So if pH is negative log base 10H, then the concentration of H is 10 to the minus pH. And then same thing for OH minus. The concentration of OH minus is 10 to the minus pOH. So the whole minus pOH is up to the power. Yeah? All right. And then one last one. If you're at 25 degrees Celsius, I'll show you the proof later. We'll make the questions harder, but just to get you started, if you're relating pH and pOH, pH plus pOH is equal to 14. Okay? So like if they've given you pH and they ask you for pOH, you just rearrange it. pOH is 14 minus pH, for example. So these are your 5 equations for now. pH is negative log base 10 H plus, pOH, negative log base 10 OH minus, H plus is 10 to the minus pH, OH minus is 10 to the minus pOH, and if you're converting between the two, pH plus pOH is equal to 14. Yeah? Okay. Any questions?
Yeah, just with because it does say it's aqueous, like
Yeah.
the state. Is that always going to be it because it's a H2O?
Yeah, so if you're writing your equations with water, that means it's dissolved in water, and
Yeah.
that's the aqueous solution. So all the stuff you deal with will be aqueous, yeah.
So we won't like do anything with like a solution that doesn't equal to 14 when it's rearranged.
Mm, It this is only at 25 degrees Celsius. That's a really good point. If they change the temperature, guys, this equation doesn't apply. Yeah. Now, normally you do work with things at 25 degrees Celsius, but this is room for a challenge question. So we'll do the basic questions first. I'll show you the proof after, and then we'll help you work out how to adjust the equation if the temperature changes. So true only at 25 degrees Celsius, and the things you work with do tend to be solutions. Yeah. Okay. Let's say the we're gonna do our own questions. I'm gonna leave the ones in the homework book for you guys to handle. Let's say I asked you for the pH of a 0.125 molar HCl solution. Okay. Now, if you're pretty good at what you do, you're going to see pretty quickly that HCl has one hydrogen in it. So if it's 0.125 HCl, it's also 0.125 H plus. Okay, so this is the most straightforward question. I'm going to walk you through the entire step by step though, because the step by step is needed when you get to the harder questions. Yeah, you can do your shortcuts with an easy question, but I don't want you to forget the steps that you're doing when you get to the harder questions, especially when you do weak acids and bases. You can't skip the equation. You do need the equation. So I'm not going to skip it, even when we're doing strong acids and bases that are easier. Okay, so step number one, you're going to give me the dissociation equation that we've been practicing from last lesson. So Lauren, can you help me out? I'm going to start off with HClAQ for you. What's the rest of my equation?
Plus H2O,
Mm-hmm.
and then an arrow.
Single or double?
Single,
Single, it's a strong acid, yep.
and then Cl minus
Mhm.
aqueous plus H3O plus
Yeah.
aqueous.
Okay, you're going to look at this. They've given you the concentration of the acid, which is 0.125. Okay. Now, we haven't done stoichiometry in a while, so I'm going to walk you through it once, really detailed, just to make sure we're all on the right track. Yeah. Josie, this is my equation. They've given me the concentration, or I've given myself the concentration of 0.125 molar HCl. So that's where I've put it. I've put it under HCl. What is the invisible number in front of HCl in the
Just
equation?
be
When
one.
when there's no number, the invisible number is 1. And then I want to get to H3O plus because that's what pH has inside. There's no number in front of H3O plus. What's the invisible number?
H, the hydronium.
Yeah, on the right.
Just one.
Just one as well. Okay, so guys, I'm starting off at HCl. The number is 1. I'm going to H3O plus. The number is also 1. This is going to sound really silly, but Josie, how do I what do I do to get number 1 into number 1? What do I times by? I times by,
One
yeah, and then let me change it just because that was really easy. If I had like a 2H3O plus here, what would I times by that time?
by two.
I'd times by 2. Okay, so guys, this is the only time we can go through it. I know that sounded really silly, but I want to make sure we're on the right track. Look at the coefficient in front of what you have. Look at the coefficient in front of what you want to get to. See what you have to times by. You do the exact same thing with the actual number they've given you. Times by 1. So my concentration of H3O plus is also 0.125. Okay, so I've got my concentration of H3O plus number 2. That's exactly what I need for my equation. So this is only a two-step process. pH is negative log base 10, H plus, which is the same thing as H3O plus. And all I'm going to do is pop it in. So get your calculators ready for today's lesson for me. What do you get when you guys pop this into the calculator? And while you're doing that, pH is unitless. Because you've put it to log base 10, that gets rid of the units. What do we get for pH? 0.903. Thank you, Celine. And Celine's rounded it off to the correct sig figs as well. Now that we're going back to calculation questions, you want to watch out for your sig figs. Any zeros before a non-zero don't count. So I don't count this first one. That's 1 sig fig, 2 sig fig, 3 sig fig. And the answer Celine's given me, that's 3 sig fig as well. I'm just going to pop it in brackets. Zeros out the front, guys, are not significant, but zeros in between two non-zeros are significant. Yeah, so this is not significant, but this 0 that's between 9 and 3 is. Okay. All right. Now let's say I'm just gonna build on this question. I won't make it a separate one. Part A asks you for pH. What happens if it also asks you for pOH? They haven't given me a temperature. If they haven't given you a temperature, you just assume 25 degrees Celsius. So if I'm assuming 25 degrees Celsius, what's the equation that relates pH and pOH, Roland, if I'm at 25 degrees Celsius?
pH plus pOH is 14 degree equals 14.
Good. pH plus pOH is equal to 14. So then if they ask me for pOH, that's just going to be 14 minus pH. You just keep on going. That's 14 minus the 0.903 that you guys had earlier. So what do you get for pOH when you sub this into the calculator? $13.1, I think. That sounds about right. 13.1 to 3 sig figs. Okay. And then let's keep on going. Let's say they asked you for OH minus. You've got pOH now. They ask you for the OH minus concentration. So pH is negative log base 10H. pOH is negative log base 10 OH minus. Josie, if I rearrange this equation, what do I get for OH minus if I rearrange this? I gave you the equation earlier. What was OH minus? So if pH is negative log base 10 OH minus, this is just a maths thing. You can or just have it memorized. OH minus is going to be 10 to the minus pOH. Yeah, so this is just in your notes. So all I'm doing here, guys, I got pOH now. I'm just popping it in. So I'm just giving you practice with all the different equations. What do you get for OH minus when you pop it in the calculator? Seven 7.94 times 10 to the minus 14. Thank you, Celine. 3 sig figs. Question: does this have units? Yes, good. This is not pH or pOH, guys. I asked you, the first two were pH and pOH. The third one is the OH minus concentration. This is going back to concentration, yeah? This is capital M. This is molarity, okay? So watch out for what you're actually getting asked for. Now, this is the first question you're doing. This is for practice, just to get you used to it. And you can see the equations are pretty straightforward. There's a reason why I led you this way, though. I want you to notice acids make H plus, right? When you write your acid dissociation equations, you end up with, in your equations last lesson, you ended up with H3O plus for an acid. And for a base, on the right-hand side, you would end up with OH minus. Yeah, that was from last lesson. I want you to notice this. This is an acid. Yeah? Oh, that's not what I want you to know. I'm just making my point. This is an acid, all right? But what did you just calculate? You calculated the OH minus concentration, which is normally present for a base. Yeah? So I want to emphasize one thing. This was like a challenge question from last lesson, but you guys, this is easy for you guys now. There'll be new challenge questions. Something is an acid not because it has H3O plus. Something is a base not because it has OH minus. Whether or not something's acidic or basic, guys, depends on the balance between the two. Okay, so as you can see, this is an acid, but there is OH minus in it. So guys, the reason a solution is acidic, I know in the equation you see H3O plus, but the reason something acidic is because there's more acidic component, H3O plus, than OH minus. Yeah, and something's basic not because it has OH minus, but because there's more OH minus than there is acidic H3O plus. Okay, so for a base, the H plus is actually less than the OH minus. So then, guys, if a question asks you what's a neutral solution, a neutral solution isn't something that doesn't have H plus. It's not something that doesn't have OH minus. When something's neutral, what that actually means is it has equal parts the acidic component, equal parts the basic component. So not one overpowers the other. It's not acidic, it's not basic. That's what makes it neutral. Yeah. That's the reason why here you're able to calculate OH minus even though I gave you a hydrochloric acid as the chemical in question. Yeah? Okay. Let's do part B and let's calculate the pOH of, let's say, calcium hydroxide. I'm going to write in words. You're going to give me the formula instead. What's the formula for calcium hydroxide? I have to give you the concentration as well. So let's go 1.7 times 10 to the minus 3 molar. COH, calcium is in the second column on your periodic table. Yeah, calcium's in the second column. The video lesson recording from year 11 on, oh, I'll need to upload it. The year 11's just here. So I'll upload it for you, the crisscross method for ionic compounds. I'll get that put up here so you can revise as well, yeah? Calcium is in the second column. That's the +2. So calcium is +2. OH is just a -1. This one you have to have memorized. So when I cross it, it's CaOH2. So let's go back to module 6. That's CaOH2. I'm gonna write the equation again. This is CaOH2 on the left. Normally I do write it with water. This one's a bit different though, guys. Calcium hydroxide, everybody, is not a Bronsted-Lowry base. Calcium hydroxide is an Arrhenius base. You know how last lesson we defined an Arrhenius base as something that makes OH minus? It already has OH minus in the formula, so it just needs to release it. Calcium hydroxide is actually an Arrhenius base. I don't need to add a H2O because it already has OH minus that it can make, yeah? So it's just gonna break up into its original ions, calcium 2 plus, and then OH minus 2 of it. So because this is an Arrhenius base, not a Bronsted-Lowry base, I don't need to do a plus H2O. It already has an OH in its formula that it can just give away. It doesn't need to take it from water. So that's that. And then, so Khadija, let's get you helping me out with this one. 1.7 times 10 to the minus 3 is calcium hydroxide. Have a look at the ratios. What do I do to get the OH minus concentration?
You times it by 2.
I times it by 2. Good. See what you do with the ratios. Do the same thing with the numbers. 1.7 times 10 to the minus 3 times 2 is a 3.4 times 10 to the minus 3 molar. I think that's correct. Correct me if I'm wrong. So I've got the OH minus concentration now. Step 2, I'm just going to pop it into my equation. pOH is negative log base 10 OH minus. So that's negative log base 10, 3.4 times 10 to the minus 3. What do you get for pOH? when you pop this in the calculator. 2.5, thanks, Celine. 2.5, that's to 2 sig figs, yes. pOH and pH have no units, so that's 2 sig figs. And then guys, just for a bit of practice again, if they ask you for pH, assume 25 degrees Celsius. It's going to be pH plus pOH is equal to 14. So pH is 14 minus pOH, which is 14 minus 2.5, which gives you 11.5. But the number I gave you in the question is 2 sig figs. So you need to round off to 2. That's going to be 12 to 2 sig figs. Okay. And then let's say they ask you for the H plus concentration. I have pH. Charlotte, so pH is negative log base 10 of H plus. How do I rearrange it to get the H plus, Charlotte?
It's 10 to the power of negative pH.
Yeah, 10 to the negative pH. And then you calculated that just then. That was the 12. When you have multiple parts in a question, round off for each part. But if you need the number afterwards, take the whole thing. Yeah. So for here, I know I rounded it off to 12, but when I use the number again, I'm going to take my non-rounded answer. And then I'll just round off afterwards. Round off at the end of each question. So what do you get for H plus concentration? 3.2 times 10 to the minus 12. Thank you, Celine. And watch out again. I haven't asked for pH or pOH this time. I've asked for H plus concentration. So this time it does have units. That's 2 sig figs. It took you a really long time, though, to get from if this question was asking you just for H plus, the reason we went this way was because I was getting you to practice the equations. But if you think of it as a question asking you for H plus, it took a really long time to get there. You calculated pOH, you calculated pH, and then you got H plus afterwards. So guys, I'm going to introduce you to one more equation. pH and pOH, really easy to convert. And then H plus and OH minus, you can also convert. So think of it in terms of variables. Yeah, if you have stuff to log base 10, pH and pOH, really easy to convert. If you have concentration, H plus or OH minus, also really easy to convert. So you don't want to have to, if you have H plus, you don't want to have to go to pH or pOH and then get back to OH minus concentration. Yeah. There is one more equation that relates these two directly, so you don't have to calculate pH and pOH. But for this, I'm going to get you guys to prove it with me, and then I'll show you where the pH plus pOH comes from. So let's go this way. What was last lesson? We said that when you wrote your acid equations, when you wrote your base equations, you always had water in it. So if you were writing it for an acid, water was the base. And if you were writing the equation for the base, water was the acid. So water is both an acid and a base. What was the word we used to describe that last lesson? It was in your quiz. Amphiprotic, yeah. So that was when you had water with something else. What you can do, if water's an acid and a base, you could put two water molecules together, and one of them will be the acid and the other one will be the base. Okay. So I don't know, let's just call the first one the acid. It gives away the H plus. When water does this, water doesn't really like to do anything else. It likes to stay as water, so we're going to use a double arrow. It doesn't actually really want to do this. The first one gives away a H plus. It's going to turn into OH minus. The second one takes the H plus. It turns into H3O plus. Oh, actually. Yeah, that's right. Now, because you have two waters on the left, the reason I wrote it separately was so that you guys could see it, the acid and the base working together. I'm just going to combine it now. This is going to turn into 2H2OL, OH minus aqueous plus H3O plus. This equation, everyone, is called the self-ionization of water. Water is turning itself into the OH minus ion and H3O plus ion. Self-ionization of water. Now, so what am I trying to get you to relate? The concentrations, right? At the moment, this is just an equation. Where do I get concentrations from? From module 5, whenever you had a double arrow, you could write an equilibrium expression and there would be concentrations in there, right? So, Lauren, this is the equation, this one here. What's the equilibrium expression for this?
The concentration of OH minus times the concentration of H3O plus over H2O,
What state is H2O?
or liquid, so it doesn't count.
Yeah, so it's just going to be the 2 on the right. And guys, because this is water, this happens to be a very special equation for water, so we can allocate the letter W to it. This is KW, OH minus H3O plus, at 25 degrees Celsius. Remember, equilibrium constants change according to temperature. So at 25 degrees Celsius, this is 1.0 times 10 to the minus 14. Okay. This is your equation that allows you to relate OH minus and H3O plus directly without having to go pOH, pH, and then back to H plus. Yeah. So guys, remember pH and pOH, really easy to convert. And if you have the two concentrations, convert it that way. Don't worry about getting to pH or pOH first. Okay, so this is your equation. Now, if we change the temperature, so earlier when Josie was asking that question, I told you guys that we'll show you later when the temperature changes. When the temperature changes, this is the only thing that changes. How did I get that number? Well, from module 5, you either do calculations to get the number, or this is just a number that's given to you. I think it's given to you. Let's have a look. Yes, here. Ionization constant for water at 25 degrees Celsius, 1.0 times 10 to the minus 14. Yeah, it's given to you in your data sheet. So if you get a question that's similar to this, like what's KW, da 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 da, but at a different temperature, then this is the number that changes. Now, how does this relate to your pH plus pOH though? Because I told you guys we'll derive the equation and show you how to change that number 14, yeah? So what are we trying to get to? I told you guys that we're trying to derive this equation here. And then I'm just trying to remind myself, how am I supposed to get to pH and pOH? I'm trying to think about what pH and pOH are. This is like negative log base 10H. This is negative log base 10 OH minus. So I'm like, okay, at the moment I have this. I'm trying to get to this. And what this is it's these. Yeah. So if I can get this over here, then I can link it to this. Okay. So I'm like, oh, okay. When I'm comparing where I am to where I want to be, I'm missing a log base 10. All right. So I'm trying to get to this thing. And for me to make it look a bit more familiar, I'm going to put it to log base 10. Now, guys, this is where a bit of maths comes in. Yeah. I'm deriving the equation for you so you know what to do when the temperature changes. Log base 10, 1.0 times 10 to the minus 14. From maths, when you're putting a log around something that's multiplied, it splits into addition. Yeah, this is log base 10 OH minus plus log base 10 H3O plus. If anyone's confused, this part here is just maths, no chemistry involved. When you put a log base 10 to something that's times together, it comes out and you add them. And then on the right-hand side, if you pop the right-hand side into the calculator, you get -14. And then, so I'm close. Your equation was pH plus pOH is equal to +14. At the moment, I have -14. So all I'm going to do, I'm going to divide by -1, or I'm going to times by -1, same thing. And I'll bring my negative over to the left when I do that. This becomes negative log base 10 OH minus negative log base 10 H3O plus is equal to 14. Yeah. All I've done is times or divide by -1 now. And then guys, have a look at this. That's pOH. And that's pH. And that's equal to 14. Yeah? That's your proof. So if you get a question that's at a different temperature and they've given you a different kW instead of 1 times 10 to the -14, you follow these steps to derive pH plus pOH to equal a different number. Okay? Possible. I've probably seen it before, but it's broken up a little bit more as more of a proof so that you don't have to do this whole thing as one question. They've probably broken it up more, but it is a challenge question that could separate the students a bit more, yeah? But we don't know what they're going to pick as the challenge question in an exam, yeah? Okay, so this is your proof, but the first thing I want to practice is just this part here. So if you have concentrations, you don't need to go all the way to pH and pOH to convert it. Why did the plus become a minus? So why did the plus become a minus? If that's a negative there, then there's a little plus in between. So because I put the box around the entire negative log base 10 H3O plus, that whole thing became pH. So there would have been plus up here. See the equation above? Oh, I just divided by -1 because I had a -14 on the right. I wanted it to be +14, so I just times the whole thing by -1 or divide the whole thing by -1. I just moved the negative over. That's okay. All right. So let's say I gave you part C. That was, what's the OH minus concentration in a 0.302 mole per liter nitric acid solution? What's the formula for nitric acid? I was almost going to give it to you, and I was like, oh, I couldn't get them to revise this. What's the nitric acid formula? HNO3, good. Guys, if you feel comfortable, set the chat to everyone, just so everybody else can see your answers as well, and we're discussing. Well, I just keep it on me. HNO3. I'm going to write the equation again. Remember, guys, if you already have concentration, you can just convert to the other concentration. You don't need to do a pH or a pOH anymore, yeah? Because you have this equation now, all right? Still need to write the equation though. Celine, what's my dissociation equation? I'll start you off, HNO3AQ. Your mic's not working. You're unmuted, but it's not registering anything. Plus H2O, it's also a strong acid. Turns into NO3 you're unmuted, but I can't hear anything on your end. Oh, NO3 minus plus H3O plus. So it's a 1-to-1 ratio, 0.302. This means this is also it's an Arrhenius acid, but it's also a Bronsted-Lowry acid because it can give it away to something else in particular. So where possible, I'll do the Bronsted equation because that's what we normally use moving forward. I'll only do Arrhenius if I can't do Bronsted. So I've got 0.312. They want OH minus. I'm not going to do pH and pOH. I'm going to go straight into, that's okay. I'm going to go straight into H3O plus OH minus is 1.0 times 10 to the minus 14. Okay, so then OH minus is 1.0 times 10 to the minus 14 divided by H3O plus. So that's 1.0 times 10 to the minus 14 divided by 0.302. So what do you get for OH minus, please? You would still get the right answer, yeah, Ma. If you feel comfortable, guys, just set your chat to everyone so everybody else can see your questions as well. If you feel comfortable. 3.31 times 10 to the minus 14. Thanks, Celine. Molar to 3 sig figs. Okay, good. Now, everything we've been doing has been giving away one hydrogen. What kind of acid do you call that when it gives away one hydrogen? What's the prefix for one? Mono, yeah. So the acids we've been doing is monoprotic. So it's pretty straightforward. But then, guys, what happens if I gave you... let's go back to pH. Actually, let's do pH first. I'm going to change it to pOH. I don't want to give it to you step by step so that you can start practicing doing all the steps on your own. Let's say I ask you for pOH of a 0.150 molar sulfuric acid. What's the formula of sulfuric acid? H2SO4, yeah. Okay. When we were writing the equations last lesson, I told you that we give away one hydrogen at a time. Maha, what's the first equation for sulfuric acid?
Plus H2O.
Mhm.
And then the single arrow,
Good, because it's a strong acid.
HSO4
Charge.
minus,
Mhm.
plus H3O plus.
Yeah, good. So it's a strong acid, so I'm going to use a single arrow. But guys, what did we say last lesson? The second equation, it doesn't like to give away the second H plus as much. The first one, it gives away pretty easily. The second one, it doesn't. What's the arrow I'm going to use for the second equation then? I'm going to use a double arrow because it doesn't want to give away the second one as much as it wants to give away the first. Lauren, help me out with the second equation. Where do I go from here?
Plus H2O
Yeah.
liquid. SO4 2 minus aqueous plus H3O plus aqueous.
Thank you. Now, guys, the issue of this is this. When you have a double arrow, you cannot treat it like the calculations we've been doing. Because what we've been doing is we've just been looking at ratios. It's a single arrow, it goes to completion. All you have to do is stoichiometry from year 11. When it ends up being a double arrow, the second equation ends up being a module 5 calculation with ice tables. The HSO4 minus isn't going to fully convert into the H3O plus, so you can't use ratios anymore. We are not up to that yet. I also haven't given you an equilibrium constant to work with. So you couldn't do an ice table calculation even if you wanted to. There's no number, yeah? How much it goes to the right to make the H3O plus depends on what the equilibrium constant is. Remember from module 5, if you wanted to fill out the ice table, you needed to know the K value. We don't have enough information yet. So what we're going to do at this point, and you'll see some questions do this as well, is I'm going to assume that both H pluses dissociate completely. Okay, I'm gonna make an assumption that the first H plus goes away completely. We know that it's a strong acid. I use a single arrow. So the assumption's more important for the second equation. I'm assuming that the second H plus also dissociates completely, which means I change this arrow into a single arrow. Yeah. Just emphasize this is an assumption. If you get given a K value, it is possible to do an ice table calculation. We'll do this in a couple of lessons time when we go through weak acids and bases. Yeah. So because it's a single arrow, I can combine it together now. My HSO4 minus cancels out. So all it looks like is this. I've got H2SO4. There's two waters on the left. It turns into SO4 2 minus. And look, these are my two hydroniums that get made. Okay. I just want to emphasize this is an assumption. If they give you enough information, you do an ice table for this. Okay. So guys, if you have an acid, it's easier to calculate pH first. If you have a base, it's easier to calculate pOH first and then convert to what you want, okay? pOH is negative log base 10 of OH minus, which you see in a base equation. So it's easier to do pOH if you have a base. But if you have an acid, it's easier to do pH first and then convert to pOH after. So Roland, if I have 0.15 molar H2SO4, how many H3O pluses do I have?
0.3.
0.3, good, because I'm looking at the ratios and I'm timesing by 2. And so then pH is negative log base 10 H3O plus, which is negative log base 10 of 0.3. Let me know what you get when you pop this in the calculator. And then I'm going to assume it's at 25 degrees Celsius again. So pH plus pOH is equal to 14. And then pOH is 14 minus pH, whatever you get for that. So let me know what you get for pH when you get it. .522, thank you, Celine. 0.522. Now, guys, this 0 at the end here is not between two non-zeros. However, zeros after a decimal are significant. Yeah, zeros at the start before a decimal aren't significant. This one is. So 1, 2, the third 0 is significant. So that's 3 sig figs. So pH is 0.522. Remember, no units. 3 sig figs. And then what do you get for pOH then? 14 minus 0.522. .5, thank you. 13.5 to 3. Would the second 0 from the left in 0.03? Yeah, so if you got another example, if you had 0.03, oh, I'll have to check with you actually. I don't know why I've forgotten this answer. Let me get back to you about this, Roland. I was gonna give you an answer and then I realized I'm not sure for some reason. My mind's gone blank. Let me come back to you about this. Yeah. If anybody knows, feel free to help us out. Is this 0 significant? I've forgotten. I've had a mind blank. I'll come back to you about that. Okay. I'm gonna give you a few examples to get a head start on to help you practice swapping between the equation, then we're going to move on from this. So jot this down. Give me the pH of, yeah, okay, yeah. pH of 0.315 molar HClO4. This is perchloric acid. If you don't know if it's a strong acid or not, if I haven't given you a K value to work with, you can't do a weak acid calculation anyway, so you have to assume that this one is strong, yeah? Give me the Mg. Okay. All you're doing is practicing looking at your equations, figuring out which ones to use and rearranging them, yeah? Let me know if you have any questions. Perchloric acid is strong. I said when we started these practice questions, if it was weak, you'd have to use K values and you'd have to use an ice table. So because I haven't given you that information, even if it was weak, you wouldn't be able to do the calculation anyway. So you can make the assumption that it's strong. So that's how you could figure it out in an exam context if you weren't sure. Roland, to answer your question earlier, 0.03, one significant figure. You want zeros after the decimal, but only if it's after something non-zero. So 0.03, this zero is after the decimal, but it's before any non-zeros, not significant. So if it was 0.030, then this would be two sig figs. Get a head start. Let me know if you have any questions. Check your answers on the board as you're going. Don't forget you're rounding off. Students lose a lot of marks for that. The first one's a really strong acid because the pH is so below 7. Remember, below 7 is acidic, but this one's really low. Any questions, let me know. Bit of a going. Let me know if you have any questions. There's E and F on. I'm just taking a shortcut because I have less space on the board. When you write your equation for F, it'll be a 1:2 ratio with the hydroxide. So the equation for F would be this. Yeah, that's how I knew to times by 2. So that's why for the OH minus, I did 2 times the concentration of magnesium hydroxide. And then remember, you have an equation to relate concentrations now. So you don't have to go the long route. For F, you could have gotten pOH and then got pH and then got H plus concentration, but you have an equation that relates the two now. Yeah. I've already rearranged it. It's 2 concentrations is 1.0 times 10 minus 14. I've already divided it over. So that might be why it looks funny. And then G, you don't have to convert pH and pOH because they've given you pOH and they've asked for OH minus. So you're just rearranging the pOH equation. Negative log base 10 OH minus. So OH minus is 10 to the minus 3.5. This is your equation for magnesium hydroxide. I'm looking for the hydroxide concentration. So I times by 2. And then once I have the hydroxide concentration, my equation to get to H3O plus is the one we figured out earlier. It's this. So then all you had to do is divide this one over to get the H3O plus. Let's do 3.5. That's all good. That's so for this one, it's just 3.2, 10 to the minus 4. However, so for G, you didn't have to convert pH and pOH because you had something for a base and they've asked for something for a base. So pOH is basic. They've also asked you for OH minus. But for H, you've got an acid in the question, but they've given you pOH and they've asked you for H plus. Okay, pOH allows you to get OH minus, but they've asked you for H plus. So here you have to convert to pH first and then get to H3O plus after. I'm assuming at 25 degrees Celsius, they haven't given you enough information about a different temperature. Anyway, we'll do that right after this. So pH is negative log, pH plus pOH is equal to 14. So pH is 14 minus 11.5, which is 2.5. And then H3O plus, I'm just rearranging the pH equation, 10 to the minus pH. So 10 to the minus 2.5. And that's 3, oh, cool. That's 3.2 times 10 to the minus. Any questions, let me know. I'm gonna give you one question where the temperature changes. Remember, all you need at 25, pH plus pOH is equal to 14. The number 14 changes. Would the last two have units? Yes, it would. Thank you. G wouldn't. Oh, G would, because I've asked you for OH minus concentration. So the last two would both be molar, capital M or moles per liter. This is 2 sig figs, and this one would also be 2 sig figs. Remember, for G, when did I get 3.2 times? When I popped it into the calculator, 10 to the minus 3.5 is 3.2 times 10 to the minus 4. Remember, pH plus pOH is equal to 14 at 25 degrees Celsius. If you want to relate pH and pOH at another temperature, you have to get a different number besides 14. Guys, you are doing the exact same thing as what we did, okay? So if you had this proof jotted down, when I change the value of kW, all you're doing is repeating this, replacing the 1.0 times 10 to the minus 14, yeah? So have this up. I'm going to change the kW and you're going to practice deriving this equation with a different number instead of 14, okay? Maybe I'll leave the proof here and I'll put the question next to it so you can see it. You're doing the questions that we just did, just at a different temperature, so you have to derive the equation again. So let's say I asked you for, let's go, give me the pOH of an acid solution with, so I haven't even told you what the acid is. I'm just going to tell you how many protons there are in there. That's all you need. Times 10 to the minus 4 at, you worked with 25 degrees Celsius. Let's just say 30 degrees Celsius. And then I'll go the kW of water at 30 degrees Celsius is 1.35 times 10 to the minus 14. Okay? All right. Let me know what you're referring to. Okay. Have a go at this. I labeled it A. Just keep on going. What did you guys finish off with? You finished off with H, so this is just I. I. Okay. So you can get pH straight away. It's a maths thing. So if you're confused about this part, then that's a maths thing. We can talk about that, yeah. You're gonna get pH, which you can just sub into the equation straight away. But when you get to pOH after, you need the equation that relates the two. You're gonna derive it following the same steps that we did. All you're doing is replacing the number 1.0 times 10 to the minus 14. Yeah, it's just a maths thing. When you put log base 10 to it, it separates out with a plus. Nothing for me to say about that. I don't actually remember where you learned it in maths. It might be year 9 or 10, I don't know. Maybe you guys don't know where you learned it in maths either.
I have never used a log ever.
Yeah, I don't remember when you guys learned it. You guys haven't seen this yet? We know this rule though, right? This isn't unfamiliar. Yeah? I don't remember either. I don't know. You don't use it much anymore in year 11 and 10. In year 11 and 12, yeah. Okay. I'm gonna go slowly, check your answer on the board as you're going, but keep on going with your attempt. I'm going to start with the proof to get you the new equation, yeah? I'm just doing the same thing I did with you guys before. Let me know if you have any questions. When you do one thing to one side in the equation, you have to do it to the other because you can't change it. You're just changing how it looks. If you've already gotten the equation, then you just keep going with your steps. It ends up being what you've been doing, just with a different number, yeah? All I'm doing here is bringing the negative over to the other side. This is pOH. This is pH. It's now equal to 13.8-ish. And this is your new equation to relate the two together. And that's it. This now becomes the questions that you've been doing, just with a different number instead of 14. So going back to my original question, if that's H3O plus, then pH is negative log base 10 of that, 1.35 times 10 to the minus 4. This here, I'm just subbing it into the equation. When you do that, let's go. 3.869. And then if you have pH and you want pOH, you normally just use your pH plus pOH is equal to 14. In this case, it just happens to be a different number. So pOH is equal to 13.869 minus pH is 13.869 minus 3.869. Cancels out perfectly, so you get a pOH of about 10. Let's go 10.0 to 3.6. Yeah? So this here is the same thing as what you've been practicing. You were just practicing deriving a different equation at a different temperature. Any questions? Okay. It's a little bit late. I'm going to give you a 5-minute break. When we come back, this is your calculations for today. We do more calculations next lesson. When we come back, I'm going to show you some of the critical thinking / applied theory questions. Yeah, so we're done with calculations. We're going to come back, apply your calculations to some theory. Okay, so you need your brain power for that. 5 minutes, grab a drink of water, whatever you need. 8 o'clock, we'll come back. Okay, let me know if you have any questions.
Miss,
Yeah.
you know how so for this question, like at the top, how it's the concentration of hydroxide times the concentration of hydronium,
Yep.
it gives you that, like the 1.35 times. I did like just algebra out of that. Like I did 1.35, so the concentration, oh my God. I did the
Yeah, you could do it that way too. You actually, for this question, there's so many, you don't actually need to derive this equation.
because I'm just looking at it and
You
I'm just,
divided it over, right?
yeah.
Yeah,
And
you
then
divided
I
it
put it
over.
in the formula.
Yeah, so you got OH minus, and then you just subbed it into this.
Yeah, and I got 10.
Yeah, that would have been the other way of doing it.
Okay, because I thought I was doing it wrong.
No, that's the other way of doing it. So this derivation wasn't necessary for this question. So let's see what kind of question you'd really need to prove this for. It would be something like let's say, for example, they gave you Let's say they gave you pH directly. They didn't even give you the hydronium. They gave you pH directly, and it's faster to use this equation. But then because proving this takes so long, if you had pH, you might as well go to H3O plus and then sub it into this equation again.
Yeah.
Yeah, so this proof was for practice, but there's different ways of doing it. As long as you got the right answer, it's fine.
Okay, thank you.
If you haven't already, send your quiz through. I can see them. Yes.
See how the hydronium is equal to 1.35?
Mm-hmm.
Why did the OH also equal like, oh wait, never mind.
Okay,
Sorry.
that's all good. All right, camera's back on whenever you're here. Few things with the quizzes. Some of them are coming back. I didn't get through all of them. I'm gonna be a little bit nitpicky. If yours came back with a little comment, if there's something missing, I'm gonna start taking the mark away because I noticed a lot of the little silly mistakes that we're making, they haven't been corrected over time. Yeah, like the little things like the states and the formulas. I'm gonna be nitpicky here so that you can correct it with no penalty instead of your teacher being nitpicky at school and then you losing marks for it there. Yeah, those little things, they mean something. Like if you have F is different from F minus. I know on paper it looks like a line, but it has consequences on the way that you apply it. in a subject. Yes, I'm going to start being nitpicky, and then let's keep track of how your attention to detail goes over time. And one more thing, most of us do really well in class, which is great. I'm not saying you don't do well in your exams. I just want to give you a word of warning. Sometimes there's a difference between how you do in class and then how that demonstrates in an exam. Class is a lot less pressure. Class is also not timed. So it might not even be the content that you do. It might just be when you go into the exam, you get a little bit nervous, and then the way you perform here with me isn't reflected in your exam marks. So I just want to let you know, like, even the marks that you're getting back for your quizzes and stuff, good. But when it comes to exam time, keep in touch with me about how you're doing in your practice tests and if those marks are improving over time. Yeah. So I know at the start we said, oh, the quizzes are for me to make sure you're doing well. And it's a good start. But when your exams start coming up and you do your practice tests, you need to keep me in touch about how you're performing in those exam conditions as well. Yeah. Okay. So just a message to pay attention to how you're doing in places outside of this class. Yeah, because you're doing well here. I want to make sure it's the same story when you're at school and things like that. And that's all. Yeah. Okay. All right. That's your calculations for today. We're going to take a break from that now. We'll go back to it next lesson. Don't worry. It's just a break for today. We'll go back to it next week. I'm going to show you the other kind of questions that you get in Module 6. Okay, we're going to start applying the theory that you sort of get out of the calculations that you do. Let's show you this one first. Question 58. The pH of two aqueous solutions was compared. You've got the same concentration of both of them, 0.2 molar HCl and 0.2 molar HCN. Explain why the HCN solution has a higher pH than the HCl solution. Include a relevant chemical equation for the HCN solution. This one I'm gonna walk through with you guys first. I'll get you involved where I can. This is a little bit more of a critical thinking question, so pay attention to the kind of comments that I make, the kind of questions that I ask myself to walk myself to the answer. Okay, and the kind of little dots, little brainstorms that I make to try to link everything together. Jot down what you think is necessary. We're going to brainstorm first. We're going to worry about getting the answer first, and then we'll worry about written expression, how to put this together afterwards. There's a few more like this. So the first one we'll do together, and I'll give you a bit more independence with the next few. Now, the question's given you the same two concentrations. And they're asking you why, even though they have the same two concentrations, they have a different pH. Okay. If you're good at this, it might already be popping out to you. I'm going to walk you through it one by one. So I'm like, okay, the concentrations are the same. Why do they have different pHs? Let me work backwards first. Let me see what pH is affected by. This is easy to do mathematically because you can just see the equation and be like, oh, what goes into pH? It's easier than like words. So pH is negative log base 10 H plus. Okay, so when it's an equation, it's really obvious what affects it. pH is affected by H plus. That's the input, pH is the output. So you're like, oh, okay. They have the same concentrations. pH is a function of concentration. pH is a function of negative log base 10 concentration of H plus. So it's like, hold on, if I'm popping in the same concentration, why am I getting out a different number? We talked about this, I think, before you went on holiday as well. When you get numbers from a question, you want to check number one, what variable is it? AKA, is it moles? Is it mass? Is it concentration? Is it volume? But you want to check what chemical that variable is for. Okay, remember what we said. Remember, if you don't have the exact variable for the exact chemical that you want, you cannot use that number. Yeah, you want the correct variable, but you want to make sure it's for the correct chemical. So let's say like you want concentration, but they've given it to you for HCl when you're actually dealing with NaOH. You can't use that number, even if it is concentration. So when I realize this, I'm like, my next point is, oh, pH is a function of concentration, but what is it a concentration of? It's a concentration of H plus. Yeah. So I'm going to go check. Okay, the two numbers that are the same, 0.2 molar. Yep, that's concentration like I want in my pH equation. Is it for the correct chemical though? My pH equation wants H plus, but the chemicals they've given it to me for are HCl and HCN. Yeah, so the variable is the same, but the chemical isn't. So when I realized that, I'm like, oh, that's the difference between the two things in the beaker. If two things are the same, that cannot explain a difference. Yeah. If you have a different pH, you're not going to use the same concentration to explain it. Now that you've figured out what the difference is what the two chemicals are. That will help you explain why the number ends out 0.7 and 5. But then it's like, how? So I know what the difference is. The difference is the HCl and the HCN, but that still, I know what it is. I don't know how it affects my answer though. So I'm trying to see how it, even though if it's different, how does that relate to my equation anyway? I've got the acid, but my pH equation wants H plus. So then as you're revising your theory, you're like, oh, the acid gives off the H plus. Because that's what an acid does, right? An acid donates a H plus. So then you're like, okay, like if each of them both have one H plus, this starts making you confused again, because like both of them give off one H plus. So if it's 0.2 molar of the acid, shouldn't it also be 0.2 molar for the H plus? But if the pH ends up being different, they must be giving away different amounts of H plus. Yeah? They both give off one H plus each. So if they're the same concentration at the start, the concentration of the H plus should be the same. But obviously that's not the case because the pH ends up being different. So then you're like, oh, they must not be giving away. If they have 0.2 molar, they must not be giving away 0.2 molar H plus. Okay? So this, as you keep on going with your thinking, you start realizing that this has to do with the degree to which H plus is dissociated. So then you start realizing, oh, it's not about the actual concentration of the acid. It's about how much of that acid is willing to give away its H plus. Okay? Just because you have 10 doesn't mean you're willing to give away 10. Stingy person. All right? So it has to do with how much you're willing to give away. That affects what your H plus is. And guys, this is something you did last lesson. What characteristic is this of an acid or a base? The degree to which it gives away its H plus or its OH minus. Maybe I'll change the phrasing because it's a little bit different from the way you heard it last lesson. The degree to which it gives away its H plus is percentage dissociation. Yeah, degree of ionization. I'm looking for a different word though. What did we talk about last lesson? Strong. Good. Thank you. Strong for a strong acid. I'm thinking about strength. Yeah. What was a strong acid last lesson, guys? It dissociates, starting with a C. Completely. Good. It dissociates completely. And what's the opposite of strong? Weak. Right. And it dissociates partially. If you're intimidated by these questions, I just want you to know that it's like this because this is the first one you're doing. When the idea is that you do so many practice questions that when you go to sit your final exams at the end of the year, that you don't get too many surprises. Yeah. It's only like this because it's the first time you're doing it. When you see so many of them, it'll roll off your tongue eventually. You guys don't believe it? It's gonna roll off your tongue one day. Okay. All right. So that's that. Which one of these is a strong acid? Guys, we know this. HCl is a strong acid. Yeah, HCl is a strong acid, and HCN is a, oh, I just wrote the same thing. HCN is a weak acid. Okay, that's the reason why the concentrations are the same, but because they don't give away their protons as much, it has less protons. So when you sub it into the pH equation, the pH isn't as low. Okay. So guys, for an acid, you want pH less than 7. The lower from 7 it is, the stronger it is. Yeah, that's why this smaller number is actually the stronger acid. Yeah. You want a pH less than 7. The smaller, the further away from 7 it is, the stronger it is. The closer to 7 it is, the less of an acid it is. So it's weaker. Yeah, that's why the HCN has the bigger number. Okay. So we're going to put everything that we said together. There's a few more questions like this so we can practice. It's fine. HCl. You're going to help me put the sentence together. HCl is what kind of acid, strong or weak? Set your chat to everyone. We're going to start forming the sentences together. What kind of acid is HCl? HCl is a strong acid. What does a strong acid do? It dissociates starting with a C. It dissociates completely. And then because they've given me numbers to work with, I can prove where they got the number from. Yeah. I don't just have to stop here. I don't just have to be like, oh, that's why it has the lower pH. I can specify that's why it has a pH of 0.7. Okay. So I'm going to keep on going with this one actually. It dissociates completely. So if you have 0.2 molar HCl, guys, what's the H plus concentration you have? It dissociates completely. 0.2 as well, because it's a 1-to-1 ratio. Yeah. And guys, what's the equation for pH? Negative log base what? Negative log base 10. H plus is negative log base 10 of 0.2. And you can pop it in your calculator to prove it. It should give you the 0.70 that's in the question. Yeah. So I'm going to take it a step further. I'm not going to be whiffy-waffy with my wording if I have the opportunity to be specific. Yeah. If I have the opportunity to be specific, I will take said opportunity. That's what I'm going to do with HCl. And then for HCN, I'm going to go, HCl is a strong acid. HCN is a, starting the W, weak acid. Good. It dissociates, starting with a P, partially, which means if there's 0.2 molar HCN, is there 0.2 molar protons or is there less than 0.2 if it dissociates partially? Less than 0.2. If there's 0.2 molar HCN, there's going to be less than 0.2 molar H plus. Okay. Notice how here I told you guys take the opportunity to be specific where you can. For HCN, I can't be more specific than this. I don't actually know how many H pluses it makes. I don't have the equilibrium constant to work with. This depends on how much it shifts to make the H plus. This is a bit of module 5. We don't have enough information. I just can't put more than this in. So there's 0.2 molar HCN. There's less than 0.2 molar H plus. So if you have a lower H plus concentration, your pH is just going to end up being a bit higher. That's all. So I'm doing this in note-taking form for you, but in an exam context, you could say something like, oh, the lower H plus concentration results in a higher pH. And then once again, if you can be specific, be specific. What was the pH? 5. So I'm going to say the lower H plus concentration results in a higher pH of 5.0. For the HCl, I could prove it. For this one, I can't, but I still want to bring in the number if I can. And that's pretty much it. I'm going to check the question again because I spend a little bit of time doing this. I kind of forgot what the question was asking me for. So I'm going to go back to read it just to make sure I've got what they want. And then when I go back, I realize, hey, hold on. They wanted me to include an equation. So that's what I'm going to do. It's going to be HCN. Roland, finish it off for me. HCNAQ. What's the rest of the equation?
For a dissociation equation.
It's always dissociation, yeah.
Yeah. Well, plus H2O L. And then it's a weak acid, so it's a double arrow.
Good.
Then CN minus AQ plus H3O plus AQ.
If you have any questions, please unmute yourself, let me know, or type it in the chat. If you just need a bit more practice, we're going to move on to another example shortly. Yeah, but if you have any questions, you need to let me know. Okay. Let's do one more. I'm going to scroll slowly just in case anyone's still writing. Question 55. 3 solutions of hydrochloric acid, citric acid, and acetic acid all have a 0.1 molar concentration and a pH of 1, 2.1, and 2.9 respectively. Explain why the pH values of solutions with the same concentration are different. Same idea as the previous question. Yeah, so one more time, guys. Clearly, if the last explanation was a bit whiffy-woffy for you, you're going to forget all of it. We're going to do it one more time clearly. Yeah. Your acids all have the same concentration. pH is a function of concentration. pH is negative log base 10 of the concentration of H+. If you have the same concentration, when you pop it into the equation, you should get the same number. If you pop the same number into the equation, you should get the same number out. Yeah? So the fact that the concentration is the same, but the pH is different tells you that that's not the actual number that you want to put in. Yeah? If that was the number you wanted to put in and you put in 0.1 for each of them, you should get the same answer because it's the same number each time. So the fact that you don't get the same number implies that that's not the number that you want. So then you're like, okay, my pH equation actually wants the concentration of H+, but the question's given me the concentration of the acid. So putting 2 and 2 together, you realize if that's not the number that I want, there must be something going on between the acid that I have and the amount of protons it actually gives away. Yeah? Any questions, let me know. If that's not the number that I want, there has to be something going on between the 0.1 of my acid and the amount of H+ it actually gives away. We've figured out now from our previous practice question that we just did that one of the reasons for acid concentration being the same but a different H+ is the strength of the acid. Yeah? A weaker acid doesn't make as many protons. So if you have 0.1 molar acid, you have less than 0.1 molar protons. That's one of your reasons. This is a slightly different question. There's also 3 acids here. So there has to be something else going on, yeah? But let's do what we can for now, because you don't want to leave your question blank. You don't have to have everything to write down your answer, just in case you end up blank. So if I know something, I'm going to add it down. So let's see what I can do at the moment. Hydrochloric acid, strong or weak? Strong, okay. Citric acid, any idea? You can say no, we're working on it. Citric acid is weak, yeah. Acetic acid. Weak. Acetic acid is definitely weak. Okay. So we're better off than we were 2 minutes ago. Look at so much character development in such a short time. But it's still not enough because you have two things that are weak. So your strength argument doesn't apply for all three. Yeah. So it's really obvious why HCl has the pH of 1 because it's the only one that's strong. But you can't use your strength argument to explain citric acid and acetic acid because they're both weak, but they also end up with different pHs. Okay. I'm gonna open it up to the floor actually. What else could be affecting how many H pluses an acid makes? This is a really vague question. I'm gonna give you guys a second, and I'll give you a hint afterwards. So, guys, at the moment we have strength, which is if strength is if it's willing to even give away. Yeah. Can you put your answer to everyone? Just copy paste the whole thing. I want to give you credit where credit's due. Yeah, good. Strength is about if it's even willing to give away its H plus. The other thing that affects how much H plus it has, have your chat box open, is the amount of hydrogen ions that it even has in the first place. Okay. What kind of, you know how last lesson you learned about strength, strong or weak? There was another group of adjectives that you learned last lesson for your acids. Hydrochloric acid gives away 1 hydrogen. What's the adjective for that? Full adjective, monoprotic. Yeah. Acetic acid is also monoprotic. Okay. So citric acid and acetic acid are both weak. So there has to be another difference that explains the pH. Yeah, you can't use strength anymore. There has to be something else. And we're figuring out now that the something else is how many hydrogens it even has that it's willing to give away. All right. If acetic acid is monoprotic, citric acid must be something else. Otherwise, the question falls apart. Anybody remember? I think I gave you citric acid last lesson. Anyone remember how many hydrogens it gives away? What's the prefix for 3? Mono, di, tri. Citric acid is triprotic. Okay. Now, if anyone's confused about one thing, you might be like, why does how many protons it gives away affect the answer if they're both weak? Okay. Which is a fair point, yeah? Who cares if it gives away 3 hydrogens if it's weak and it doesn't even want to give it away? All right. Fair point. Fair point. Okay. Well, I'm going to demonstrate it to you. Let's say you had 100 of the citric acid, and let's say you had 100 of the acetic acid. Yeah. But because it's weak, let's say only 10 of them that actually wants to dissociate. Okay. You have 100 molecules in total, but because they're weak, 90 of them, 90% of it doesn't even want to break apart. Only 10 of them are willing to. Yeah. But because acetic acid is monoprotic, it gives away 1 H plus per acid. If 10 acid is willing to give away a H plus, you'll end up with 10 H plus, right? Because it gives away 1 each. But then because citric acid is triprotic, if you have 10 that's willing to give away, tri means 3 per molecule. So if you have 10 molecules, you'll end up with 30 H pluses. See that? So I know even if they're both weak, of the amount that's willing to give it away, the citric acid will still make more. Yeah? That's why the pH still ends up being different. Okay, so I know they're both weak, but of the ones that are willing to give it away, it'll give away 3 each compared to 1 each. So you still end up with more H plus at the end of the day. Yeah? Any questions? Let me know. All right, so the strength argument is the same as the previous question that we did. The second one is, if you want to put it in terms of just a word, I don't want to use stoichiometry. It's not the correct one. Number 2 is going to be the number of acidic protons. Acidic protons are the ones it actually wants to give away, yeah? So it's affected by strength and it's affected by the number of acidic protons. So let's work on structure here again. There's one more practice question that I'll leave for homework, and then you can work on structure and written expression there, and then send it to me for feedback. But this one we'll do together also. So let's go. Hydrochloric acid is, this one is the same as the previous question that we just did. So I'll do this one quickly. I'll get you involved with the next one. So hydrochloric acid is a strong acid. It dissociates completely. I'm going to add it's a strong monoprotic acid. So then if you've got, what did they say? 0.1 molar. So if you've got 0.1 molar HCl, you will make 0.1 molar H plus. So that's why the pH is negative log base 10 of H plus is negative log base 10 of 0.1, which gives you the 1 that's in the question. And I'm going to draw the marker's attention to that. I'm going to stuff it in their face. I'm going to say, hey, it's equal to 1, just like you gave me in the question. Although I'm not going to write it as that. I'm going to tell it as given in the question. Okay? I'm going to show to the marker, hey, I'm giving you the exact number that you gave me. Yeah? And then for citric acid, I'll just do it in order. Citric acid, it's a weak triprotic acid that dissociates partially. So notice how I'm following the same structure as my first one. I'm just changing the word. This is partly what it means by sustained, yeah? So if you've seen like cohesive, logical, sustained in like a written response criteria. Logical is it makes sense. Cohesive means it ties together. Sustained, just like sustainable practice, is you can maintain it throughout. AKA, you're maintaining the structure, yeah? So if I'm going to start off by telling you if it's strong or weak, I'm going to do the same thing with the next paragraph. Weak triprotic acid, it dissociates partially. So 0.1 molar acid makes less than 0.1 molar H plus. And that's why you have a higher pH of, what was it? It was 2.1. Okay. Then I follow the same structure with acetic acid. I'm going to go acetic acid. It's a weak monoprotic acid. It also dissociates partially. But, it dissociates partially, so 0.1 molar acid makes less than 0.1 molar H plus. Okay, so I'm following the same structure, but because I've got 3 acids, guys, my answer starts changing a little bit because the citric acid and the acetic acid paragraph are starting to sound the same. Yeah? They both dissociate partially. They both make less than 0.1 molar H plus. So I need to explain the difference, deviate from the structure if you need to. Don't do it more than necessary. So it's starting to sound the same, so I need to address why the pH is still different, yeah? So even though acetic acid dissociates partially, because it's monoprotic, even though they both make less than 0.1 molar H plus, the H plus concentration in acetic acid is less than the H plus in citric acid. So what am I saying here? I'm saying citric acid and acetic acid both have a low H plus, but acetic acid is even lower than citric acid. Okay. They both have a low H plus, but because acetic acid is monoprotic, the H plus that it has is even less than citric acid. All right. Okay. So because of that, it has an even higher pH of, for acetic acid, that's 2.9. Okay. These are the sort of thinking questions that I'm referring to that applies the theory that you learn in a further. Yeah, so there'll be a few more of this in module 6 coming. All right. If you want to pop these into proper sentences and send it to me for feedback, then please do that. Yeah, okay. Can you jot down for homework for me questions 37 to 58? Questions 37 to 58. Okay, very good work.